All right. Okay. And I should use this microphone, right? Yeah. Okay. All right, bonjour. Bon après-midi. Merci beaucoup pour l'invitation. J'aime beaucoup le thème de la conférence Innover Ensemble parce que c'est ce qu'on fait aussi à Stanford. Euh, et puis, bien, ça fait longtemps que j'ai fonctionné en français. J'ai fait mes études à l'École polytechnique fédérale de Lausanne, en Suisse, mais ça fait plus que 30 ans que je travaille à Stanford. Donc, je vais parler en anglais, ça serait mieux pour les choses professionnelles. Et puis, même si vous voulez demander des questions en français, je crois que ça ira. Okay. So I will, explain a bit how we work together with the industry to innovate together, because I think in our field, that's really the only way to do it. After all, we are an applied field, and if what we do in academia doesn't find its way in industry, is not relevant for industry, I'm kind of saying, what's the point? So worldwide, I see really everybody now facing similar challenges, which is kind of unique because if you a decade or so ago, if you went to different parts of the world, there were different challenges. But now everybody has to achieve more and more objectives on projects, not just safety, quality, budget, schedule, but also many sustainability concerns. You find it everywhere in the world. Everybody is facing changing demographics in terms of the people we build for, but also the people that are available to manage. In every enterprise and every company I visit around the world, they say, yeah, our experienced people are retiring soon, and we don't have enough experienced people following, so we need to find very different methods for design and managing projects that allow somebody with less experience to still be successful. So these are, some of the key challenges I see around the world, whether I'm in Peru, whether I'm in Singapore, whether I'm in, Switzerland, what have you. And obviously we have to therefore find different ways of designing and building our projects. And what I would like to show to you, no, I guess I'll jump ahead a little bit too much. I would say, of course, we have to innovate incrementally in the context of the work today. But I think we also have to create the vision and the foundation for what I will call breakthrough innovations, dramatically different ways of working. Because I don't think that today's processes, adjusted a little bit, will really help us tackle the problems we face globally at scale. So that's really what we're working towards in our work. So since, I really like the projects this morning, and I look forward to the others this afternoon. In the context of things that get talked about a lot, I just want to say a few words about things that really excite me, and then things I'm a little bit skeptical about, but would be happy to adjust my skepticism if you give me good reason for that. But I really continue to be excited about parametric modeling and multidisciplinary design optimization. I think we can do a lot more of that with that. I like also, as I think it was Danielle presented, sort of AI methods that really support us humans and automate repetitive, tedious work, or give us new capabilities, allow us to do things we can't really do, see patterns in data that we couldn't see ourselves. Like digital-driven methods for managing digital and physical production, visualizations of all kinds, sort of really good visualizations that support collaboration, and the concept of circularity. Some things that I'm skeptical about is Gen AI and ML on the basis of information from past projects. I'm really not sure about that for two reasons. Few companies or organizations that I know in our field have actually reliable data from the past that is organized in any kind of reasonable way. And second, I'm not quite sure what we want to learn, because I see practices we are going to do to be quite different, much more digitally supported. So I'm not quite sure what we will actually learn from looking at data from experiences that were largely sort of in an analog way of doing work. But you can adjust my thinking if I see this wrongly. And the other one is, as I love the concept of circularity, but I'm wondering about really the feasibility of implementing circularity at a component level. I see quite a bit of work in that area, but I'm not sure. Given our need to really understand the quality of a component once it's no longer used in building like this, and then finding a marketplace that matches that with other components. Other aspects of circularity I see a bit more feasible. So just wanted to preface this. So our approach to industry or academic collaborations has really sort of three parts. First of all, create the foundation, so a solid foundation for innovation by making sure that industry projects are managed, run in what I would say the best currently available methods that you can just implement because they have been proven to work. We call that virtual design and construction, and I'll illustrate that. Then on that basis, to bring incremental innovations into these practices, into those projects, but also with an eye towards potential future breakthrough performance, and then prototype some breakthrough innovations. Like create a vision, like what could actually be possible, and I'll share some examples of that. Always with industry participation. So every student that works with me and many of my colleagues has to be able to function in the real world, has to be able to perform in the real world at a reasonable level, because if they cannot, then they cannot gain the trust of professionals on which they depend to get data, insights, access to real situations, which then challenge the conceptual thinking and provide really a foundation for strong conceptual thinking. Likewise, we challenge our partners in industry to think a little bit more conceptually than they often do. So I really enjoy when we challenge each other in these ways. I think you'll see that through the project examples. So in terms of creating a solid foundation, of course, we do that through our master's program. It's called Sustainable Design and Construction. Lately, it's been quite popular, which is great. But also, and I'll focus on that here, professional education, and in particular, I'll focus on actually the VDC certificate program. I should have put the arrow actually one lower. We've done a couple other, or are doing a couple other professional education programs, but the main one we've been doing is focused on virtual design and construction. So let me just share a couple examples there, and then move to research projects that happen in the context of projects managed in this particular way. So today, you would expect that any project would leverage latest technologies like BIM. You'd also expect that they use lean thinking and methods, that they use collaboration tools and approaches, and have a kind of objectives, key results, metrics way of approaching projects. I think it's pretty straightforward, obvious. The reality is that the majority of the projects that I know use some of these methods, but it's quite rare to find a project or a company that with intent from the beginning of every project carries out the project with all of those components mutually supporting each other. Because yeah, in reality, of course, you have to define the objectives of the project. You have to measure towards, manage towards them. You need to collaborate with others. You need to do so efficiently, and information is the lifeblood of any project, of any organization. You can't do anything without information. You can't do anything well without good information. And many of your projects this morning focus on that. I know these are terribly obvious statements, but I look forward to the day when I don't have to make them. So This is what prompted us to develop this concept or this method, which we call virtual design and construction, which does bring together all of those elements. It connects the definition of objectives from the client and project team perspective with how people work together, how they use technology, and the production processes that they set up and follow. And of course, they are mutually connected, right? If you need to create a particular kind of information, you need the workflows for that. Likewise, you can't carry out certain workflows without certain information. You can't have productive collaboration without accurate, up-to-date information. You can't really take advantage of the opportunity to do things concurrently if you don't design your processes that way. So that's basically these kind of interactions that we teach in this professional education program. And so these are the last few groups of professionals we have been teaching in various parts of the world. This is usually popular method in Norway, which is cool to see because they have some very cool projects there. So you see a little over 200 Norwegian professionals basically learning virtual design and construction in our professional certificate program. A third owners, a third designers, and a third builders. And you see somewhat smaller groups, but still nice groups in Switzerland and in Peru. These are lately, for some reason, the main places where people have wanted to do this program. So let me share with two examples from projects how people are using VDC. One is a few years back, but still one of the most impressive achievements I've ever seen a project team achieve anywhere in the world. And this was done, and the project team signed up for this incredible challenge because they had actually done the VDC program, and they said, hey, if we use VDC from the beginning all together, we can achieve this. Because the task was for the Pan American Games in 2019 that were held in Lima, to build all of the Olympic level facilities. In 2013, the Peruvian government said, yes, we will host the 2019 Pan American Games. In 2017, they were like, this requires Olympic level facilities. How many of those do we have in Peru? Oh, 0. How many has anybody here ever built something like that? No. So they had 16 months to design and build these Olympic level facilities for the Pan Am Games. And so this team, led by the second largest contractor in Peru, COSAPI, stepped up to the plate and said, we can do it. And people thought they were absolutely crazy because, of course, your reputation is usually on the line. You know, finishing those facilities a month later will not really help you. And so they did achieve it. And they'd achieve it by really very carefully defining the objectives that I had to pursue. I'll go here pretty quick. I probably have too many projects to show, but the idea is to give you an idea and then happy to connect on any of them, collaborate in any of them, if you like, afterwards. So they were very clear. I mean, obviously the timeline was really driving, and of course the quality of the facilities they had to build were really the key things. So they started the project with really intense collaboration, where over, this is a picture of one of those collaborative sessions, over the first 10 weeks of the project, because you got 18 months, so you got 16 months, you got to get going. Over the first 10 weeks of the project, they had 2-hour so-called ICE session. ICE stands for Integrated Concurrent Engineering. Integrated meaning many disciplines. Concurrent, now, like together, not sending emails and looking at things and trying to get back to people. No, we solve engineering, we solve the problems now. So they had 10 of one of these 2-hour ICE sessions every day. In each of these sessions, they looked at 15 critical issues. So they really worked through all of the critical issues in the first 10 weeks of the project collaboratively. This kind of rapid cycle I've seen in other projects, having huge benefits because it reduces the number of balls in the air, right? And actually allows you to focus on what you have to actually get done and move on. Instead of lots of just in case things that we find being tackled in many projects. They modeled everything in BIM. They didn't say, well, we don't have time for that. Said, no, we can't afford, right, any mistake in construction. So we have to make sure everything we design is buildable and of course then usable and operable. So they had 60 BIMs, 60 different models, 10 main uses, 3,000 issues solved before construction. 90% of the project staff work daily with BIM. It wasn't some sideshow, it was how they did the work. And of course, they modeled the production processes, the many production processes very carefully. They also had ice sessions to develop those production processes. For example, just a small example here. The designer was Arup in the UK because they had the experience from the London Olympics. But then, of course, they had to be built in Peru. So they had lots of collaborations, had to define the common data environment, how they're going to use it. So for that, they, for example, did that also with an ice session just to illustrate, again, the connection between these VDC components. And just to highlight some of this, I mean, I'm sure you've seen this on projects as well, right? Formulation of the processes, so everybody's on the same page and follow them. And then also definition of the metrics, production metrics they're going to use along the way, like every week, to see whether how things are going or whether an intervention was needed. So this is just a very quick glimpse. The games, I think, were a huge success. Facilities worked well. And I think it's quite remarkable. You know, the project team said, yes, we can do this pretty crazy task because we will manage it with all the best tools available that we have today. More recent example is actually here from Max. He was in the previous VDC. We have just started a new program like this, but was in the cohort of professionals that graduated last year from the VDC program in Norway. He's well, I'll introduce him a little bit. The program works like this. Basically, after a week of introduction, everybody goes back to their projects and applies VDC and reports 6 times, 6 months on how that's going, and basically keeps learning them by themselves and together. And so what you will see is what he did to bring the concepts that we teach in VDC to his organization and his projects. Max is a senior, I guess I'll jump around a bit, is basically in charge of all of project management for Lidl Sweden. Lidl is a supermarket chain. I don't know if you know it, quite big one, I think mostly in Europe. And he was hired, yeah, so they build these kinds of stores. He was hired because Lidl Sweden was in this place. So each bar is the cost per construction, cost of construction of a new store in a country where Lidl operates. So you can imagine how much fun it was for the country manager of Sweden to go to headquarters in Germany with the other country managers and see this job. You're the winner of the highest cost per square meter for your stores. Of course, that's not the distinction they wanted to have. So they brought in Max. They said, we have to do something, we have to change. Clearly something is not working as well as it should in how we manage our projects. Of course, what Max heard when he joined that organization in that role was this. Well, what do you expect? Come on. Each store is unique. I mean, how do you want to compare a store in downtown Stockholm with a store at the outskirts of a small town, you know, out in the country? I mean, they're totally different projects. And by the way, anyway, costs in Sweden are high. Everybody knows that. So where else should we be but on the right side of this chart? Max was like, well, yeah, that's true. Labor costs and so on is high in Sweden. But is each store really unique? I mean, this you hear a lot around the world, right? Whether a company builds schools or hospitals or bridges, you know, they're all unique. And to some extent they are. But Max was like, well, let's see if we cannot somehow simplify, you know, these stores or create more of a common basis. So over 3 years, he was able to move Sweden to this place in this chart. Reduced construction costs by 45% by bringing the VDC method to their projects consistently, not in one-off way, but across the whole organization. And basically, he did that by just systematically looking at things that were actually the same. And by that meaning, of course, some physical components, some physical parts of the project, of the stores, but also the development process, the decision-making process, just as importantly. And so basically they developed solutions that could work for every store, and the store could just say, yep, that actually works. We're done. Before, right, they would hire a designer, make the design, review it, you know, et cetera, et cetera. Takes a long time and ends up with a sometimes questionable approach. Basically, what came out of this is a master BIM, as they call it, at level 350. So quite detailed, that every manager building a new store has to start with. And then they have to build their project on the basis of this master BIM. Of course, some aspects are local and unique, so they can adjust those. But this allows them to only focus on the things that are truly unique. And they can focus on that. The rest is like, we've done it. We have learned our lessons. We know what to do. And then they're expected to provide updates, improvements to this master build from their store so that the next store can start with an even better starting point. Improvements in terms of technical solutions, but also improvements in terms of just, you know, the information in the BIM, how it's being used and so on. So this has had quite a good effect. The decision latency actually currently is this was actually a few months back. Now it's actually quite a bit better, even better. But even a few months back, they made 75% of decisions within 1 week, and almost all decisions within 3 weeks. And you could say, well, that's okay. The key thing is not to change your decisions, you know. So yeah, you can make a decision fast, but then what's the point if you change later? But they only change 1 in 33 decisions. So they also make good decisions that they can stick by. Actually, the most recent data is their decision latency is 1.1 days with a variance of 1 to 5 days. So quite predictable. Before it was, let's see, I think I remember right around 5 weeks with a variance of 1 to 16 weeks. So nobody could really count on when the decision was going to happen. They're able to put the design for a store out to bid in 2 weeks instead of several months before. The design cost was reduced by 80%. The designers might not like it, but from a client perspective, not bad, as we say in Switzerland. And of course, they have to pay for the upkeep of this master BIM, but actually found that even though it provides much more value, that's actually cheaper than what they paid to maintain sort of the information they had to give to bidders anyway, before, as you can see. And they have seen, because they go out to the market with a detailed bill of materials. So a client has said, this is exactly what we want. So this is what you need to bid, general contractor. So the variance in the bid has gone down from plus minus 30% to plus minus 3%. So much more certainty. So these are, a couple examples I wanted to share from bringing VDC to projects. I think the deployment of VDC is within reach of any organization because we're not expecting an organization to do something that hasn't been proven. in terms of how to manage production, organize processes, orchestrate processes, how to collaborate, the technologies, setting of objectives, and so on. But that provides, for me, a better foundation. Why I'm interested in teaching this is I want to start innovation, improvements, in the context of what I would consider good practice, not average practice. Because I think that's what I feel our role is, to advance together with industry. So I want to share a couple examples of bringing incremental innovations to projects. There's quite many. I'll give you the list in case you want to connect. And if we went to recent projects, there would be many more. But one example is around virtual reality, construction robots, and generating data-driven insights. I want to just briefly share. So this work is by Simge, a PhD student in my group, originally from Turkey. And this was actually the early days of her VR involvement. She should finish her PhD next year, and has focused really on articulating the value of VR design reviews in the coordination of MEP systems for complex industrial structures. But she started by working with on the largest wastewater treatment plant in San Francisco during the pandemic, where the project team sent headsets to all the key participants, and so everybody was in their home office, but then working together in the VR to, in this case, improve the maintainability of the key mechanical room of the wastewater treatment plant. I imagine similar things like this happened around here as well. So I think this really, I think was a nice way of supporting a team with bringing an innovation to the project, because she could, master technology, understand what the project needed, and help bring the technology to the project, and then document how well that was working. Things that are difficult to do for a project team, when they're in the middle of the project. Other example is where we worked, this work by Cynthia. She finished her PhD a couple of years ago, actually an architect from Uruguay, and but she wanted to do construction robotics. And the first case study we were able to do with a company in Norway, Cruiser Smith, was, I think, the first deployment, at least that I could find, of a robot that did actual work on site. And this was really interesting because they did, this is for drilling the holes for the installations in the concrete slab. And they did half the project with the robot and half the project traditionally. Like, was it like amazing for a researcher to see that opportunity? And so, we worked with them to understand really the differences, not only on site, but also the collaboration work, the BIM modeling work, and so on. And I was initially quite skeptical when Cynthia wanted to work on construction robotics. Said, we've tried this, normally I don't have that attitude, but there I had. And she said, well, why don't we try? I said, okay. It's tough to tell an enthusiastic student, no, you can't do that. And so I have to say, I was really surprised by the data we found on this project. I mean, for the first application of a robot, I think it was quite cool because, the schedule was a little bit better, but dramatic improvement in the ergonomics of the work, 98% reduction in the strenuous work, better quality, better accuracy, cleaner site. Cost was a bit higher, 13%, but I thought, okay, for the first application, I think it's not quite good. And so we also published with our industry collaborators, like here, paper on this, quite detailed paper exploring the difference between the traditional work and the robot-supported work. And we have now done about 40 case studies in 8 countries with about 30 different general contractors on the application of various types of robots on site. This happens through a class we do, construction robotics class. Actually, you would be welcome to participate in the class if you want to do a case study here. I would love that. We have worked with other universities in that context. It's in our spring quarter. And basically, this is a summary of what we found across all of these case studies. Safety and quality were always better in the robot-supported work. And schedule and cost, very much a mixed bag, as you can see. Sometimes also quite a lot better, sometimes quite a lot worse. Because in some cases, the robot is still quite expensive. And so if you want to have, if you want to be on schedule of similar schedule, then the cost is very high. Or if you just work with one robot, the costs are kind of okay, then the schedule is actually not better. But in other cases, we have seen also some significant improvement, as you have seen. So the third example I want to briefly share is gaining insight from all the data we can collect. It's really quite remarkable over the last few years how much data we can collect, not just in the factory, but on site in terms of production data, actually also for the design process with common data environments and so on. Many ways of collecting data. I want to focus here on the example left, an IoT-enabled crane hook that's on the market by a company called Versatile. Started in Israel, but now in the US and I think other parts of the world. And basically this crane hook gives you data on every second of what a crane is doing. So you're getting quite a bit of data, typically about 20, depends on the project, of course, and number of crane lifts, but on the projects where we have been working with general contractors, it's about 2,500 data points a day. So over a few months, there's a little bit of data to look at. And so I want to show kind of some insights you get from looking at the data. This is also done in the context of another class, a class that I actually teach at the moment. We'll have final presentations in a couple of weeks. We have done a similar project. So this was a collaboration with HDCC, the largest contractor in Hawaii, building condo towers in Honolulu, typically 43-story condo towers. So this is data from 2 condo projects from last year's class, just to highlight the kind of insights you get from the data. For example, the data showed that there is a 15% learning curve with every doubling of the same types of operations. We've always talked about learning curve, but I had never seen it really quantified. So that's super cool because this learning curve happens even if the lifts are higher and higher, right? You go up. So even though you have to transport things faster, the lifts are, the cycle time is actually less because the crew clearly learns. It was also then interesting that just after we saw the data, I happened to be on one of their sites and we ran into the most experienced person from HDCC building these concrete towers. And we asked him, said, hey, is there a learning curve? And if so, how much do you think it is? And he said, yeah, it should be about 15%. It was amazing. He hadn't seen the data. He had absolutely not seen the data. And then we said, well, here's the chart. This is all the data. And so this was kind of a confirmation for me because I believe that is with these types of methods, we can make younger professionals with less experience still successful in managing projects because they can rely on the data, but we need to make sure that the data, actually useful. So that was kind of cool. There's actually also, so they were happy to have a quantification of this learning curve. They're also a bit surprised to see that the cycle time when they do overtime on Saturdays was quite a bit higher than the normal days. It was also interesting to see the cycle time in overtime during the weekdays was actually less than the cycle time during the normal day. I guess the people wanted to go home, and on Saturday, I don't know, they figured we were there anyway. We're not totally sure why, but anyway, it was interesting for the company to see. It was also a bit of a surprise that the cycle time was longer before and after the holidays. After holidays, they could kind of imagine because people get back and they have to remember. But before, they had actually expected to be maybe faster because thinking people are kind of anxious to get out of here. But the data showed no, it actually tends to be longer before and after the holidays. The data confirmed, but now they had also data that indeed during the rainy seasons, the cycle times are longer than during the non-rainy season. As you can see here, with the shaded part is the rainy season in Honolulu. It also showed that it really pays off when you do as many consecutive lifts of the same type as you can. Then you have much less idle time than when you don't. So in terms of planning the work, right? Because you don't want idle time. I mean, you have 43 stories to build, right? The crane sits idle, not a good thing. So basically, what this showed is the data allows you to quickly see, the analysis of the data allows you to quickly see where things are going just fine. And you have benchmarks to other projects that are not just anecdotes. And it allows you to see where are the outliers. And then the project team can focus on those and see what's going on here. So much more productive use of people's expertise. We continue to work with HCCC, also a bit on the research side, to build really sort of a data-driven construction management approach. And for that, they need data about everything. So here they get data from the crane, but the data they don't have is how is the work they actually do, they self-perform the concrete, how is that actually going? But they have a 4K camera on the tower crane, so we have video of the construction of the whole tower, of all the towers they've done. And so we are in the process of developing a computer vision method that recognizes, right, the like how many people are laying rebar from when to when, in what zone, how long does it really take to place the concrete, etc. So that we can then feed a digital twin of the production process with the actual data that we can then simulate and understand, understand the production better. And again, give less experienced project managers a tool that encapsulates a lot of the experience from the experienced project managers. Sort of through all of these projects, we used the digital twin framework that we came up with. Since the word digital twin came up a few times, we were asked by our industry collaborators, couldn't you come up with like a framework like 1 to 6 or 1 to 5 as we have for autonomous driving in terms of levels of digital twin? And we tried and tried and tried. We couldn't figure it out. And eventually we realized why. Because as complicated as autonomous driving is, you're talking about one actor, a driver, doing one action, driving, with one product, a car. Now, in our industry, we have many actors, architect, a rebar layer, mechanical contractor, what have you, many actors doing many kinds of actions on many kinds of components at many different scales. So like how can we come up with like level 0 to 5 or whatever it is, framework of digital twin that fits all of these? So instead, the best we come up with is this framework where we say, okay, for everything you do, you need to get data, you need to make sense of data, you need to make a decision on the basis of data, and then you need to implement the decision. Then you can get new data. And you have routine work, and you have non-routine work. So basically draw a line of where do you see the digital twin. Does the digital twin, like in this example, in this particular example, the digital twin provides support of getting data. Doesn't get all the data, but provides support. It autonomously, automatically makes sense of the data in routine situations and suggests a decision. But then the humans implement the decision. So whatever the situation, right, you can now draw with a line the performance of the digital twin you have today and where we'd like it to be, understand the cost it would take to go from one level to the next, and the business value you would get from going one level to the next. So we have quite many projects going on right now that work with industry partners to bring innovations to their projects. Quantifying the environmental impact of industrialized construction practices. If you go to the websites of all kinds of industrialized construction companies, one of the first things you typically read is, it's greener. We have gone to many of them. Not a single one had data to actually show how much, or is it really? So we're working on that. I shall share these in case any of you have interest here. We'd love to collaborate, of course. We've been working with building owners and operators on strategies and policies to reduce embodied carbon in buildings. Yeah, operational carbon is big, but embodied carbon you spend now. So if you do a net present value analysis of the carbon, it's also very good to save carbon like at the beginning of a project, which is the embodied carbon. So we worked with Stanford buildings and real estate people and developed policy and approach to reduce the embodied carbon by 20% for the time being. Formalizing client objectives. I think this relates quite closely to Brenda's project this morning. A multi-stakeholder metrics framework to assess MEP system performance. Yeah, we're excited about automating, optimizing design, but for that you need the criteria. What is optimal? And as soon as you start to think about it, you realize from whose perspective. And we haven't been able to find actually a framework that puts all of this together. A worker's perspectives on factors affecting work and productivity. If you look at the studies on productivity, almost all are done from the management level. Very rarely have workers been asked by themselves. When the workers were asked in surveys, they were typically given a list of factors that managers came up with, or asked in the content, or asked when managers are present. So we've done one first study on the turnaround industrial project in Louisiana, where we were able to talk with almost 200 workers and managers. And we'd love to actually do another case study somewhere where somebody would be interested in giving this kind of access. Another project looks at the value of building the interaction between businesses and community resilience, and how do you make a facility resilient and help the community be resilient, and vice versa. I think from a business risk management project process, quite important. Then an AR interface for simulating the use of construction robots. Yes, there are simulation environments you can use, but they rarely actually exactly the situation where the robot will be used. And we have seen in the 40 case studies, often little gotchas. And so the idea is if you have an AR interface, like a foreman can actually try using a particular robot in their space to make sure that it looks like it's really feasible. And then finally, a natural language interface with BIM. Now that's becoming a little more popular, but I think that was one of the first ones, or in that case, in that projects in that way. So now I want to share a couple sort of more breakthrough focused examples of work that really push the envelope as far as you can push it, and give a glimpse of what might be possible in the future. So first one is focused on this on automated optimal design of steel structures, which really fits in the context of collaboration and automation in the VDC framework. This was work done a few years ago by Filippo in collaboration with the project team, DPR Construction, a developer, structural engineer, steel supplier, fabricator, erector. And Filippo came to me and said, Martin, I think we can fully automate the design of course, a code-compliant structural steel for a major building. Much bigger than what we can show here. Like in the morning, we had to sign NDA, of course. So we can't really show the building, but these were buildings in downtown San Diego. So the kind of buildings you see there. And I said, what do you mean by optimal? I said, well, really cost optimal, not just optimized for material cost, like methods you can find today, but optimized for material fabrication and erection cost. So it took us a while to find a project where everybody was willing to share all of this data, at least with us. Well, eventually we succeeded. It took a few tries. I shall not name the companies that said no, we're not interested. So then from a research perspective, okay, we were wondering, okay, you can do it, but is there a value on a project? But also from a practical perspective, of course, they were also interested in that. So this is how we try to align the research question and interest with the commercial interest. So we used one building to develop the method, where basically Filippo worked along with the project team, was always just a step behind, but could validate that the automated model was actually producing results that were credible, past master of, and most importantly, the structural engineer. And then we were able to apply the method on a second building. And so this data from the second building, where the automated method produced the design in 1 hour versus several weeks for the typical method, and saved almost 10% in the cost of the structural steel. But this is a composite structural steel with the composite with the deck, metal deck, and concrete, typical structure on the West Coast. And it's interesting to see that pretty much all the savings comes from the details. So this also shows the value of doing things concurrently. Because yeah, in today's process, you do the conceptual design first, and then later you do the details. And you might be lucky that your conceptual design aligns really well with what turns out to be producible, affordable details, or not. And here, I mean, it wasn't too bad, but still, right? Through the iteration, because we do it concurrently, we can pick a conceptual design where the details also work together, and you find the optimum between, right, the main structure and the details in terms of, cost. And so that was also interesting to see, because people always tell me, yeah, Martin, integrating project delivery is cool, but how do I know I have the cheapest cost? Well, if your competitive bidding saves you 10%, maybe you should go ahead if you can afford the time. I mean, this is one case. It's not necessarily always 10%, but in this particular case, it's 10%. So that's an example of, right, a kind of a breakthrough, I would say, innovation, automating a major part of a design. Imagine if this was really available, the interaction between architect, developer could be very different. If you knew for every architectural scheme, you have an optimal structural design in 1 hour, you could start to think of developing projects quite differently. Of course, we need it on the mechanical energy side as well. So there's still some room for a few PhDs. Another example is building on the vast amount of production data we can now collect is really truly data-driven construction management. We were able to prototype this together with a precast company. This was on a parking structure near San Jose Airport, about, I think, 1,200 cars, something like that. And as a precast company, you live and die economically with ordering the right number of parts for tomorrow. Because the precast components are made in the yard, and then you have to tell them, tomorrow, send me these parts or these components. And if you guess right, then you have exactly 8 hours worth of work. If you guess wrong, you have wasted capacity if you don't order enough, or you have to pay overtime. This is a super good company, the most competitive precast company on the West Coast, Clark Pacific. I guess here is the cost that they incurred if they order under or over. They were on average 2 hours off each day. So this is a good company. This is what they're able to do with today's method, which basically based on using average production rates, because that's all the time you have to collect data. You don't have time for somebody to stand there all day and really pay attention. So we were curious, again, if we use the detailed data to manage to decide what to order tomorrow, because we're learning, right, on this project every day what is actually going on, could we make better decisions? And so this is the data for the whole project, 61 days of installation. In gray, you see what the project team actually ordered. So you can see on some days they were pretty good, because if they ordered exactly the right number of parts, they would be on this black line. So here on these days, they were actually quite good, but in other days they had 4 hours and more of overtime that was required. And then we basically pretended to do the project again, just on the basis of the detailed data we get from the crane hook, the thousands of data points a day. And you can see the color dots. I won't go into the difference here for sake of time, but on almost every day we could have made a better decision. The matches more closely what then actually happened. And overall, we could have reduced with the data-driven methods the forecast error by 50%. So only plus minus 1 hour off. And we fully automated, had to, the planning process for the next day. You can't make it by hand, right? looking at thousands and thousands of data points. So giving somebody on a project 2 hours off, or 2 hours to do something else, or going home 2 hours early, whatever the case may be. So this was a kind of a glimpse in sort of, I think something we have to really work on is this digital twin of production processes. We've seen the value of a digital twin for our product, right? BIM and its applications. And we don't have something like this for our digital and physical production processes. Not just something to look at, but something to really simulate, compute these processes. So that's a key thing we're working on, and again, love to collaborate on that. The last example I want to share is a project we are quite early on. It relates to, in a way, digital twinning of the operation maintenance of, in this case, roads, but physical access in the context of circularity. Right, the closest loop is the maintain and prolong loop. So to the extent we can maintain and prolong the life of a project, we don't have to throw it away or recycle it, take it apart, etc., which is much longer, much more. And so, of course, for roads, you can detect defects easily now. It's, you know, as in startups, you can just basically buy the technology. What is still difficult to do is to scan a road now and in 6 months, and then really match up each of the defects with the defects from 6 months. It's, at least the research we have done shows that this is very expensive to do, out of reach of project teams. So this is basically what we're working on, trying to see how can we match different scans to understand, yeah, the road was fixed, or that this is getting worse, this is getting much worse here, much faster than over here, so that we can match up the damage and the change in damage with the appropriate maintenance and fixing strategy. Because of course, you know, the sooner you fix something, the cheaper. This is data from California, ranges from $6 per square yard to $200 if you have to fully rebuild the road. So, right, but then you have, of course, also, you can't send out a maintenance crew for a little crack. So you need to figure out what is the minimum economic order quantity. And so this is what we want to enable, this kind of relationship between understanding the state of road and how it develops, and what are the best methods to maintain it, fix it. So we have a couple other examples of breakthrough innovations. One maybe, I think, a little crazy. We'll see how far it gets. Basically, idea for an architect, as soon as it starts sketching, to immediately build a semantic BIM in the background, right? Looking at millions of buildings that have been made and said, this sketch could be this kind of building. And so that you can more rapidly give feedback. So Alberto is an architect, has worked an architect, and he says, this was the most frustrating thing for me as an architect. I would create a sketch. The client, we would fall in love with that building. And then a month or two later, we would get feedback, you know, from some analyses. Yeah, this is some kind of a dream you're having, this is not going to happen. And then we had to painfully change the design, right? And so I'd love to get this feedback quickly before I fall in love with a particular design. That's sort of his motivation. We're working with a company building industrial facilities to basically create a design method that optimizes the use of industrialized construction methods in the construction of those facilities. And we want to bring sort of marrying local construction practices, industrialized construction practice in developing parts of the world. Simi, the PhD student, is from Lagos, Nigeria, and she basically, you know, observes there, as in many other places, just an incredible lack of affordable housing. And basically also observes that the local methods, yes, they work from a cost perspective and from a comfort perspective, but are too slow. And when you show up with industrialized construction methods, yes, they're fast, but they're too expensive and to build and operate. So trying to see how we can marry the two. So in summary, as you have seen, try to show you sort of this range of building a foundation for innovation, bringing incremental innovations to projects, and then having a few examples where we, in the context of real situation, prototype what we would consider breakthrough innovations. So basically our work looks at, how ready are emerging technologies for deployment, like robotics, virtual reality, developing data-driven methods, learning from the past, learning from possible futures through many simulations. One thing I showed the digital twin framework. We have quite a few more frameworks. What's also missing, I see, is basically management frameworks. How do we manage projects company with this dramatic increase in digitalization and different skills you need? So that's another thing we're working on. And throughout the whole thing, I think you see this theme of really creating clarity between what does some kind of machine computer do versus what do people keep doing. That's also a theme that, of course, many of you, almost all of you, had this morning, which was great to see. So hopefully that has given you an idea how we help to try to contribute to innovation together with industry. We keep learning. I think industry keeps learning, so we can actually tackle the challenges we face. So to wrap up, this was focused sort of on technology, but underlying all of it is really thinking about sustainability in economic, environmental, and social terms, and in terms of top line and costs, so we can do more good and less bad. I'm a bit sad when many of my colleagues at Stanford interpret sustainability as minimizing environmental costs. Of course, we need to do that, but I think the real challenge and opportunity in sustainability is much bigger than that. And for that, we need technologies, but we also need some different frameworks to do projects. And so one of the most remarkable examples I've seen, just to sort of close here on this point, is the Aquatic Center for the Olympics in Paris. That was really a cool project for me to learn about, built by Bouygues. Because whoever decided in Paris or in France about the Olympics said, okay, we should use at least some Olympic facilities to upgrade these stressed areas. So they put the Aquatic Center into Saint-Denis, which is not, the most thriving part of Paris, and they wanted to uplift the community. And they said, okay, bidder, you have to design, build, and then operate this Aquatic Center for 30 years. And operate means you run the Olympics, you run the European Swim Championships that are on the horizon, and the rest of the time, you run the Aquatic Center as a swim center for the community. Parents can bring their kids to learn swimming, there's a water polo club, whatever, right? And so as I talked to the project executive, he says, when we looked at this, we quickly realized that the big cost for this project was the treatment of the humid air for 30 years. So we did everything to reduce the size of the swim center to the maximum possible. So we built this pool that is really expensive because it needed to be configurable into 26 different configurations by moving the floors, by moving the walls, etc. I still would love to go and see that. It was still, the concrete was under construction when I visited the project. But that allowed us, yes, we spent more money in design and construction, but that allowed us to keep the volume small and give a chance to have operating costs that are manageable given the purpose. And I was reflecting on other swim centers, right, that have fallen into disrepair. The Aquatic Cube in Beijing, I think the swim center here in Montreal, is it used from the Olympics? I don't know. In Munich, they fall in disrepair because they focused on design and construction costs. And they said it would have been much cheaper to build a bigger hall, right? Build a few pools and put a roof over it, but we would have been impossible to maintain. So in addition to technologies, I think creating sort of the right framework for projects also is really quite important. So thanks for listening to projects we're doing. Looks like you're having as much fun as we have, which is great to see. And if you can, please join us on some of the upcoming events. We have a focus on project production management on December 5th. together with the Project Production Institute. I need to find out if that's also streamed online. And then we have the Industrialized Construction Forum, 11th version of that on February 4th. That's available in person and online, that I know. So thank you for having me.
Thank you so much, Martin, and the messages that you conveyed, especially with the last slides, it was very, very nice to hear about sustainability, all aspects of it, and etc. I see already we have a question.
Thank you for the great talk. I don't know how familiar you are with the concepts of DevOps in software engineering, but I think that a lot of the overall approach that you're presenting, right, which is an evolution from agility and so on, is really get the work done, learn from it, get the best practices, and work on continuous improvement, right? I think that what you present in the VDC and so on is reuse of best practices at the process and at the component level, right? To try to.
Yeah, it's in that sense very similar. I haven't formally studied it.
No, but that's.
Many of my students come from that world as well. But it's basically the idea. You have to break up the work.
Yeah.
So break it up, but don't forget that you also have to integrate.
You have to integrate, and no matter how good you do of a job of testing and simulation and so on upfront, which is all helping, don't try to get it perfect because you won't anyway. It's more important to get the work deployed, right?
Yes.
And learn from it,
Yeah.
right? And construction is maybe a bit more difficult sometimes to recover from mistakes or whatever, but simulation is there for it, right?
Yeah.
And then you learn, and then the best time around, and then you have this convergence, like the case.
Yeah. And that, the little case, I need to write it up, really shows that basically, they used to, early in the days in like 21, 22, the cycles of improvement were roughly every 2 months. When, they said, okay, we have a better master BIM now, and now the cycles are every other week. So, I mean, that's basically
Absolutely.
Underscoring your point.
And the other point, I think, which is quite similar, we are in complex systems here, right? It's a multivariable optimization problem. And we all know that you can prove local optimization, but you can never prove global optimization. So the only thing you can do is be aware of it and monitor, right? Anyway, thank you very much. Very inspiring.
No, thanks for the comment.
Dr. Fischer, thank you very much for sharing your insights. Just a brief context before I jump to my question. In both my master's and my PhD, AI has been the central theme. And I think I speak for many other students in the room, online, or maybe even your students, that as much as I find it very exciting and animating, but on the flip side, sometimes it's very overwhelming when we look at the pace at which the technology is advancing. So you mentioned the critical role of collaborations, tight collaborations with industry, but at the end of the day, so many things should work, well for you to have access to those collaborations. So I'm wondering, what would be your advice, especially for early stage researchers, when we are crafting our personal research agendas and we still are passionate about this field? So how we can navigate our, concerns that, okay, how I should be working and keep faithing that maybe I can create some meaningful contributions to the field.
Yeah, and you're absolutely right. And that's one of the reasons why I love having a community, because it's impossible for any one of us to keep up with all the developments, and exchanging that and sharing that is a way that the main strategy I have to not end up somewhere in left field. And so in terms of the challenge you have, I ask all of my PhD students to work at 3 levels and iterate rapidly and frequently between these 3 levels, which is at I don't know if you want to call it bottom level, but you have to give me a real situation of a person in industry that has to achieve something, do a job. Because at the end of the day, you're in a field, as I said, in an applied field. So if you're developing some kind of concept that's not useful for at least one person doing one job, I don't know, what's the point? And they struggle with that. Because I mean, that has to be extremely literal. Like on Tuesday morning, Eric, the structural engineer, is trying to do that. And that's the best he can do, but the best he can do should be able to do, it should be that. So then create a vision on that. How should the result or the efficiency, what should be better? And then reflect on that and say, okay, if it's just a matter of implementing some technology, then it's not a research problem. So then articulate in that context, what is the conceptual gap? What is missing that doesn't allow that performance? And so that's the conceptual level. And then why does that matter in the big picture anyway? Give me sort of a big picture story. So at Stanford, the students they typically start with the big picture story. Then they kind of get the concept story, and then they really struggle with the detailed story. And I have lately sort of come back to that and said, okay, no, I have to hold their feet to the fire. Because when you have a sharp, detailed story, you will get the validation criteria for your concepts right from there. And you can actually tell the story, and you can engage with industry because you'll get feedback. Yeah, you're actually dealing with an issue we really have, or an opportunity we should have, or this is really not that important. But now that I think about it, something else is, right? So that's where we can also really make sure we find the right industry partner.
Okay, thank you so much for the presentation. I have many questions. I hope I find time that's later maybe. But regarding the project from sketch to semantic 3D, looks to be very dream project,
yeah.
Super ambitious. But
yeah.
So many levels, like many layers this project has, but starting from the training data, I was wondering how much of BIM models with details related to costs of good quality you have in hand to be able to feed this project.
Yeah, that is challenging. So that is still an issue. There is some data sets. I would have to put you in touch with Alberto where we stand on putting those together. We are actually another project which I should have all the lists. I was afraid I would forget one project. Is where we are looking at finding the buildings with the best potential for energy efficiency retrofits from publicly available data like Street View data, satellite data. And what we have learned there is the classification you can do on the basis of that data is too rough. I mean, you can classify, you can say fairly accurately, whether in the European scheme of like A to G, a building is like between, in the top part or the bottom part, but it's not enough to sort of pinpoint energy efficiency strategy. And for that, we need to, at least it looks to us, we need to train sort of a model to recognize those opportunities. But for that, we would need a data set. And we haven't found a data set where you have and you need a data set with exterior and interior. And so we've developed a method which we have to improve a little bit more. And then we plan to release the data set and the method to synthetically. So we have created 100,000 buildings synthetically where the interior and the exterior match, but the variation is not big enough for then a machine learning model to sort of learn a sort of rich enough context. So we need to tweak the algorithm a bit to create more synthetic building that looks to us like the most promising method to get a data set we can start to train the AI method on.
Thank you. Very interesting. We will follow the advancement of the work.
Thank you so much. I think it boils down to, from my perspective, decision making. Basically projects are a series of decisions and promises and decisions. And it was interesting around the VDC framework, and the first project around Lima is saying, okay, we were able to make decisions. And I'd be curious to see around the psychology behind that. And if you were able to look into that, one issue we face is people aren't habilitated to make decisions. They don't want to make decisions. And they don't want to be held accountable to those decisions. So how is the context around the Pan Am Games made so that people were, if you make a decision and you make a mistake, it's okay. We'll fix that. Not, it's your fault and you get fired and go away.
Yeah. Yeah, that was probably should have left that one slide. Given your question, should have had left one more slide in, but I realized I was way too ambitious already. Because I have a slide that has the recommendations from the project team. And the first point is make sure the owner is on board with decision making. So it took them a little time because that was, of course, also new to the owner. But they were given the urgency of the situation, the burning platform they had. They were able to bring the owner on board and basically participate. Yeah, we're there and making decisions. And that's what I've seen. So that the little example is very much about decision making. Max says, project management organization has to be a decision making machine. That's what he calls it. And so everything has to be set up for that. And but he's the owner. So he is driving this, and it comes as a big surprise to the designers and builders that worked the first time on one of his projects. Oh, this guy really means business. Oh, and he's like sticking to the plan. And he expects this information to be available. And he wanted a BIM. He really meant it. I mean, they learn fast, but there's a learning curve. Yeah. So I think it's from what I've seen, it's really a question of leadership from the top management on the owner side, and then the key designers and builders. And you have to accept that mistakes you make, and then you fix them. Yeah, and then you learn, right? Exactly. And so building that trust and building that relationship, you have to actually be deliberate about. And actually, I've seen the creation of a BIM is really a good tool to build that trust, because you can see, the guy actually did what we said or not. And that builds trust. But the other part, that how Max builds trust, he has a very standard way of doing meetings, but building a lot of empathy. Has parts in the meeting that, these decision meetings he has, where actually builds empathy between the group. And so the people actually, after like even a few days, open up and say, sorry, guys, I know my deliverable today is not up to speed. I had, I don't know, sick family at home or this other project. And the people understand and help. And so I'll become like a team, like a sports team. Like not everybody has, the top day on a team every day. But as a team, you can iron it out. Yeah.
Last one. Thank you so much for joining us today. It's a real honor and pleasure to having you. And my question is around IPD. It's been nearly a decade since you introduced the simple framework for IPD. After all this time, how you see this approach evolving in the industry, and despite the growing trend we see toward more collaborative approaches in the industry, why we haven't seen yet a widespread adoption for this approach?
Yeah.
Thank you.
Yeah, and I also had a slide on that in there. But I really liked your focus on capabilities, because that's also what we're focusing on. So because whether IPD happens as a contract scheme is, one thing, and that's why we changed the name of the book. The title of the book used to be called Integrated Project Delivery. That's how it started. But eventually it dawned on us, we says, no, we should call it Integrating Project Delivery, because integrated project delivery is understood as a contractual approach, and very quickly people will come with excuses why the next project will be the one where we'll do it, which you hear a lot. But integrating is something everybody can do. Everybody can integrate a bit more. And I should have maybe reflected on basically, if you look at all the projects, there's some aspect of integrating to advance the capabilities of integration. And yeah, to us, that seems to be the way to think about it. Of course, if you have a project where you can, it's set up as an integrated project in contractual ways, fantastic. But you can't necessarily count on that.
Thank you so much, Professor Fischer.
Thanks again. Merci beaucoup.
Uh, I just want to make an announcement, which is a very, very, very preliminary one, but we're looking with Formation Continue de l'ETS to bring the VDC program here in Montreal at the ETS. So maybe starting next September or something like that, you'll have the opportunity to learn together with Professor Fischer and to create this community of best practices level innovators. So like go to the best practices level and start innovating from then on. So. And now we continue with the next block of presentations. And my colleague Ali Motamedi will take the floor. Go ahead.
Okay, we will start the third block with no delay. We are already a bit late. Thank you so much for the presentation again. No, it was very interesting and we all benefited from an amazing presentation. So in this block, we talk about artificial intelligence, more specifically computer vision and natural language processing. Also, there would be one presentation on advanced visualizations, all in the context of digital twin, and one presentation on decision support systems. So we start this block with the presentation of Amir Hossein.